Great. Okay, cool. I'm going to try to go through this quickly because right now the connection is still okay. Um, so, Scarlett, thanks so much for inviting me. I mean, this is a really exciting group to be part of and just to be presenting to you. The question how AI can affect anti-corruption has been sort of on my mind for quite some time, and I think it has to do with this sort of general hope that we saw in the corruption field that, it has been heralded as like the next frontier in anti-corruption. There have been works already quite early by Per Avik and colleagues from CMI outlining how we might be able to use AI to fight corruption. Other organizations have also quickly realized that there might be huge potential. And so what we did in our work as scientists sort of is to critically evaluate, when is this hope warranted and when might it actually maybe lead to exaggerated expectations. And so we believe. Yeah, so basically where I left off is basically to talk about like what are the actual reasons to be hopeful. So one of them is the fact that we can use AI and particularly its autonomous learning abilities, but it's also able to, like I said, do some of the tasks that we are maybe not super well equipped to do. So if you could go to the next point, besides these learning abilities, we also have maybe reasons to be hopeful in terms of the computing power. So basically, we now have systems that are increasingly powerful, and therefore they can actually sift through ever larger data sets, and they can actually help us to detect patterns that were previously quite difficult to be detected. And this can help to really keep track of complex corruption schemes, right? And you can think of cases that I've cited here, like these massive data leaks, the Panama Paradise Papers, and so on, where we have massive data that is analyzed, and AI can really be useful there, largely due to this computing power that is now available. Another reason to be hopeful, if you could maybe go to the next one. Yeah, so that's basically a point that the late Danny Kahneman made in his most recent book, Noise. And that's basically the idea we know from so much research who are working in this space are well aware that we humans tend to be quite partial in our decision making. That's some of the research that we've done in behavioral ethics, showing that people are often swayed by personal preferences, by who they know, who they're friends with, and so on. But if designed properly, algorithms do not have that. And that's the point that Daniel Kahneman makes. It's basically saying like we are quite noisy in our behavior and our decisions, whereas algorithms can, at least if we program them properly, be consistently impartial. And algorithms don't care about money, right? So if you think about, for example, trying to prevent bribery schemes between citizens and public officials, if you're actually doing this through an algorithm, this might actually reduce the risk of bribery because the algorithm doesn't accept a bribe. That's the basic idea. Besides these reasons to be hopeful, there's also reasons to be maybe a bit more careful in our expectations. So that's the next part. You can actually just click through all and see them all, and I can go through them. For some reason, it's all numbered number one. It should be one to three, but I don't know why it is the case. So we have a few challenges. The one is actually, for those of you who are a little bit familiar with AI, you know that oftentimes the training data really determines the outputs. And there's this saying among computer scientists of garbage in, garbage out. So if you don't have good training data, then you will not make very good predictions. And with corruption, we all know that it's very difficult to actually get reliable data about the actual occurrence of corruption. So actually training algorithms on existing data sets is a real challenge because what do you use as an actual reliable measure of corruption? The other one is that you have a very thorny challenge to calibrate the algorithms properly, meaning we need to be careful that the algorithm is not overly sensitive, meaning it, for example, flags all kinds of things that are actually not corruption as corruption, and people might become desensitized, but also vice versa. You don't want the algorithm to actually let corrupt practices go unnoticed, unflagged. And so, especially with the case that corruption has such a strong social stigma, tools that would, for example, communicate such predictions to the public need to be calibrated very carefully. And there's this case, for example, of a tweet bot in Brazil that tweets out suspicious activities by politicians based on openly available government data. And there they have this very, thorny challenge to settle: how sensitive should the algorithm be? Should it rather have a false rate that is maybe too high, meaning it detects too many people as corrupt, which I accept, or vice versa? That's a real challenge. And then finally, we have what we call the paradox of control. So it means like we think that algorithms are particularly promising in contexts where corruption has become very widespread. Because here, replacing people sometimes can really make a big advance in terms of reducing corruption. But the problem is, if you're removing humans from the equation, or you remove humans from the loop, then also no one has final oversight. And these systems that go are much harder to keep in check. So there's a real also kind of paradox of how much we should actually involve people and how much we should allow them to tinker with the algorithm. So maybe let's go to the next slide. And let me make just one point that I think is also, so you can see it in the paper that I shared. So I think the way we implement these AI tools really has an important influence on whether we should be hopeful or maybe a bit more skeptical, at least so far. So if you click through it, you will see that basically if these governments are partnering with large tech companies in order to develop AI systems to fight corruption, we have found a few examples where this was rather like a fig leaf, meaning that actually it was often used, for example, in this case of the Zero Trust program in China, to spy on its public officials rather than actually fighting corruption. So there is a real risk that if top-down governments are implementing such algorithms, they might actually create an infrastructure that can be abused, for example, for surveillance. So there's a real risk that top-down implementation can actually consolidate existing power structures. And as a final point, if you go to the next slide, there's some reason to be hopeful, and I think there's exactly this point. If you could click one further, there's exactly the point of our group that we're talking to right now is really like, if it is used by bottom-up agents, meaning NGOs, journalists, civil society organizations, there's a real potential that AI can help us to detect corruption, to empower these civil society organizations, and therefore maybe also keeping power holders in check. So that's basically one of the main points of the paper. And maybe, I know I'm running out of time, so I would say maybe you can click to the next slide. Yeah, so that's basically what I've summarized, and maybe you can go to the next one. Right. So I mean, maybe we can skip to the last slide, and then I summarized a few examples. You can read about them in the paper. We also find in linking here a paper that we are about to submit, where we actually develop algorithms that are communicating corruption cases to the public, how they should be designed, going back to this dilemma that it's not so easy to calibrate them. And overall, if you could go to the last slide, you will find all of our work there linked with QR codes and open access links. And I'm very curious if you have any feedback or want to read more about it. I'm also available via email, as you can see in the bottom. So sorry again for not being able to have a more stable internet connection. I'm about to go to the tunnel to London, so I think it will only get worse.